zooming. I think I'll use your mic only. Hello? I'll use your mic. So today what I'm going to talk to you about is Hadoop 23 that we have deployed at Yahoo, which is also known as .NET. We're going to talk about the experiences, customer impact, and deployment issues that we face. And after that, I'm going to tell about how we are doing deployment because we have an extremely large set of nodes, and we have done the deployment in phase match.
Okay, I'll be back there.
We have a lot of customers
I just needed him to start talking.
and we have somehow mitigated the risk and done this rollout. So first of all, welcome to the Hadoop Distributed. And this is my introduction. So my previous background was mainly focused on MPI and other systems that I worked on parallel computing before moving on to Hadoop. So my agenda is basically going to be on the overview introduction because I sense many of you in this room know what Hadoop 23 is. So I'll go over briefly what this new next-gen Map-Reduce does. Many of you must have seen slides on this, but still I thought that it would be justice if I go over a few slides to tell what this new infrastructure does and how is it beneficial to Yahoo. Then I talk about the experiences. There are two important components for Hadoop 23. One is known as YARN, yet another resource negotiator, which is a replacement for Job Tracker, and another is federation, HDFS federation, that means federating name nodes and giving you multiple namespaces. Right? That's what it does. And finally, I'll move on to Hadoop 23 experiences that we basically have. So the Hadoop technology stack at Yahoo is similar to this, right? Wherein we have HDFS that we have all deployed on Hadoop 20.205 and Hadoop 1.0. That's the current release that Yahoo is running on. It's a stable release and it's been running on 40,000 and more nodes, right? It has been running since there has been minor updates to the versions starting from 2008 when we adopted Hadoop 20, and there has been incremental releases every few months, right, based on priorities. And then finally we have arrived at this. So we have HDFS that's also deployed on a small cluster. We have Map-Reduce high event rate that we use intensively in Yahoo, right, for doing data analysis and warehouses. We have edge catalog that we basically use to drive either ping or high, and then we have the highest level management layer wherein we run our workflow applications. So many of our customers use this structure and we have made sure that it's run on Hadoop 20. So what are the highlights on Hadoop 23, also known as .NET? The biggest challenge that we faced was, this is a major Hadoop release in about 3 years, I would tell, because since I have been at Yahoo from 2008, there was after Hadoop 80, we never updated up 20, right? We never updated or updated. We did incremental releases for security, we did incremental releases for small patches, but not a large scale change, right? So the thing was, this was it was built by previous model nodes, and it was later stabilized and now being pushed into releases by Hadoop Champion team. So they have done a great job in basically pushing out new releases, making sure it's stable, getting patch fixes, making sure it needs to work, right? And they have done an excellent job at that. For Hadoop 23, what we needed for Yahoo, right, was very specific. We wanted YARN that's very beneficial for Yahoo because it helps you to run paradigms other than Map-Reduce. So having that in place allows you to run different application types which your customers need. So that was the advantage that we wanted to adopt on Hadoop 23. And we also wanted to have Hadoop federation. That's another feature I talked about from Hadoop 23 we wanted in Yahoo. The main reason is we wanted to consolidate storage because we have duplicated feeds coming from various data sources that is distributed in various threads, right? So we want to consolidate storage, make better use of our storage, and Hadoop Federation, HDFS Federation allows for that, right? So that's the main reason we adopted these features and adopted this release, right? Federation is undergoing customer testing. It would make more sense if multiple of our grids are updated to Hadoop 20. So this is still under Federation, but Yarn has been basically deployed on a few customer-facing clusters, right? One thing that people get confused is Hadoop 2.0 is a release that people talk about in the community. That targets high availability name nodes. So Hadoop 20 does not do that as of now, right? The current release that deployed in Yahoo does not do the high name node availability where you have a zookeeper instance and other instances to make sure that you fail over whenever there are problems with the name node. That we are not addressing here in the current release deployed in Yahoo. The biggest problem that we faced was we have 100 or more customers who are using Hadoop 20. So upgrading to a version of Hadoop 23, which is totally new, is extremely complex, right? So what we did is we gave sufficient time for the users to migrate, and we had a schedule in place to make sure that they are successfully migrated to the new version, right? So we took a sample cluster, installed Hadoop 20, a large enough cluster, which we call a sandbox, installed it with the latest update of Hadoop 20, and let it soak for a good amount of time. And we allowed most of our customers to do testing on that, right? To make sure that all their application code compiles, they run successfully, meeting customer SLA, right? And we did that in a phased manner too, because if all of them get onto the same cluster at the same time, it's extremely difficult to basically manage that, right? So we had to do this in a very phased out manner. And also the rollout that we are doing in Yahoo is also in a phased manner. We are not going to update all our grids at the same time, right? We want to do this in a manner that is consistent with the customer timelines and also when they need to get updated, because they have business value, right, and when to get updated. So there are end of year monitoring. So we don't want to be too aggressive in pushing out Hadoop 20 on all the grids at the same time, right? So we need to do this in a cautious but phased manner. So let me talk about the two important components and what they get to the table for Yahoo. One is known as Yarn, that we have seen presentations before, but let me highlight what it does. It's known as yet another resource negotiator. It is the redesign of the current implementation of Job Tracker and the Task Trackers in another framework wherein you can run multiple different paradigms, right? So the current Map-Reduce, as most of you know, is in this manner. You have a client, you have a job tracker, and client submits Map-Reduce jobs to the job tracker. The job tracker finds resources where it can execute these jobs. It launches map-tasks and reduce tasks, and these basically, when they complete, they inform the job tracker back that they're done, and the job tracker manages the life cycle of the application. The biggest problem with this design is the job tracker is very hard to scale, right? You can't get in, you can't run a huge amount of applications and get response time, because you have a single component that is relying on application lifecycle management. So what you want to do essentially in Hadoop 23 is basically split these two. So what the job tracker is doing right now in Hadoop 20 or 1 or 0 or 2 is it's managing both the application lifecycle management as well as it's managing the resources, right? It's doing both. And when it tries to do both, it gets very hard for it to scale. And you have RPC timeout requests, things are slow, right? Customers don't see the SLA and you meet the SLA, right? So what you do is you split this in a nice manner, wherein you take the cluster resource management and put it into something known as resource manager, and you split the application lifecycle management into a component known as application master, which is the user process, not the user process. So in that, the application is much, you can scale much better. So there are three components now instead of a job tracker and a task tracker and tasks. You have a resource manager which is just the scheduling of resources. So you can plug in any scheduler you want with the resource manager. It can be either capacity, you can also do fair share, or the default scheduler that comes with. You have a node manager, which is very similar to a task tracker, but here what it does is it's the per machine region. Does the same thing, but only thing is the concept of a container, which is either a map task or a reduced task, depending on what it executes as. The node manager manages the life cycle of each of these tasks or containers. And the application master is per application. So whenever you provide a Map-Reduce job or an API job, let's say, right? You have an application master, the master that controls how each of the tasks in an application are launched and terminated. That is dictated by the application master. So if you look at the schematic, that's going to show you this is how the architecture looks like. You have instead of job tracker or something like a resource manager, where you can first make a request to submit a job. The resource manager then launches an application master, which is then responsible for managing the life cycle of the map and the reduced containers. Right? That's what it's done. If you look at this picture, the client launches, contacts the resource manager, gets a resource that it can launch a job, gets an application ID. Then it starts out as an application master, which then negotiates containers, right, on the need basis. Right? So what this gets to the table for Yahoo and most of the other clients is you can control the way, you can write your own application master for different paradigms. Right? There is ongoing work, but with this design in place, at least you can think in that direction. Right? And that's the advantage that this new design gives us. So if you look more, this is how it works. So you have a client, contacts the resource manager, launches these application masters, which in turn launch various containers. They then do the shuffle, they then make sure that all these intercommunication between these various containers happen. Right? So all the complicated logic has now gone into the application master. So the resource manager can scale to higher number of nodes. So that's the advantage, right, for doing this. So if you see over here, this is how the flow of this happens. So if you submit a job to the resource manager, the node manager is always giving update of how many resources it has free. So whenever the application master wants more resources, he just contacts the resource manager and finds it out. Right? So that's the good thing. Right? So once we did this installation on the clusters, this has been also talked about as Another Meetup. I'm taking some slides from there. So the experiences of Yarn, these were the high points that we found out. First thing is, it is stable, right? So that's the first thing that we need when we are deploying our customer machines, that it works well, right? Because we don't want it to be going down every other hour, right? So it's been running stable as of now, right? We support something known as web services that's extremely helpful for our customers, because right now, previously, if you look at our previous implementations, screen scraping and all these were done to come up with tools to manage your application, right? How's your application perform, right? It's sort of very tricky, but we have some, so this has web services that make life much simpler for higher level developers, right, to work on this architecture. It has been supposed to be stable as of now. Current build that we're running Yahoo is 23.2. Right now we have no problems as such running on clusters of 2,000 to 3,000 nodes. We had no issues. We also ran some small tests to simulate a 10,000 node cluster, and it runs fine there. Right? And also one good thing that happened with deploying Yarn was in Yahoo we had Hadoop 20 itself had a fixed map and a reduced map. So for every node you had a fixed map slot and a reduced map. So or the number of mappers that you can launch in a cluster are always constrained, right? So you have let's say 100 mappers and 50 reducers. Now what happens is there are many applications within Yahoo that require higher memory to run, right? One mapper itself requires 20 GB to run. For example, a maps application requires to process an image, it requires 10 GB right? So the previous models were not able to help run these applications. Now here, since we don't have a fixed map and reduced slot, we can launch a container that can take a good amount of resources and run, right? So we can do all that. So that helps us to basically, run or basically map Hadoop basically make these applications which are not running in Hadoop before to run in Hadoop. So that was the advantage that we found when running Yahoo. There are a few applications that are not scaling and now they are able to do. Also, we did some performance numbers. These are very initial. This was done out of grid mix. We found that there were some good read throughputs that we got higher. Sorts, shuffle, grid mix, all of them were running much better because of the changes that this new paradigm brought us. Right? For example, when we did sorting, there was something like IO percentage for the record. There was a setting, right? Wherein if you have a large percentage of records and you always spill out of buffer. So there are some changes that we did so that we could automatically figure out when it would fill and in a manner we could basically avoid lesser spilling in the map sort phase. Right? So that was one example. In the shuffle, there was an obvious fix that we did wherein we reused the same connection, right, for fetching the HTTP data between the mappers and the release. So all these changes help to make it better. So it's not that these numbers were immediately set up out of 20 and got it. It's over a period of time because initially there were tests in which there were fixes in Hadoop 23 that went into making this better. Because initially there were some tests that were not doing that way. Also, Hadoop 23 has something known as Uber application master. So if your data is extremely small, you don't want to run a map-reduce program because it takes overhead of launching a mapper, launching a reducer, and coordinating this whole process, right? It takes more time than the actual job, which may just require a few seconds or a few minutes to run. There are cases in Yahoo, right? And even the sort job, for example, a partition job, just take a few minutes. So you can run this as a Uber application master, wherein you run it locally, like a Hadoop local, you run it locally inside the application master as a single Java process. And it can give you much better runtime. And that is one thing that this definitely helps us with. Also, we are investigating these paradigms. For example, there is research work done in Yahoo to integrate Yarn with Spark to do more real-time processing. Same thing with real-time streaming at S4 and Storm. Graph processing we're trying to integrate. MPI, there has been some work in the community. I looked at some Jiras. There has been work, but we are yet to adopt it. But hopefully this paradigm will give you the ability to run these. Yarn will give you the advantage to run these different paradigms because it helps Yahoo to better analyze their applications. There has been issues so far with Yarn, potential deadlocks, scalability issues. There is no general job history server, right? Failures are hard to debug because this is something new, right? Many of our customers face problems with debugging these things, right? So for them, a new look and feel, everything seems to change. So definitely they had issues, right? And we went over these. Some of them are fixed and some of them are still open. In the non-federation, so that was one feature that we adopted and we got some results. This is the second feature, right? A federation, right? A non-federated HDFS architecture is basic 101 wherein we have new node and multiple data nodes and they do the work. On federation, what we propose is you have block management managed by the names node and you have storage which is done by the data nodes, right? So what happens in the previous non-federated architecture, you have a single namespace one. You have a single namespace and that's managed by one name node, right? And whenever your name node is down, that's the end of your root. So you can never get your root and that's the disruption of your work, right? So what we do is, in the federated architecture, what we essentially do is, we basically have multiple name nodes and what happens is these data nodes store data not only from your name node, but not only the name nodes reporting, it reports to multiple data nodes. So what we do is, in a way, we can basically average utilization across these various data nodes. Also, we can allow for duplication of data, because many times what happens is when you have a large destination, you normally have duplicates of data stored across various data nodes, right? And we can avoid that when we consolidate the namespace. And it allows for better scalability also. So that's the advantage that HDFS gives us, right? And that's a good feature that Yahoo is planning to adopt when it basically has higher clusters of maybe 20. So every client will have a client-side mount table. You use the mount table to mount various namespaces. Testing is underway to do this. So what would essentially the user would impact is you have to use a file system known as build file system to mount, right? So if you have scripts that use HDFS, you have to replace that UFS. So that's a direct impact that will happen, right? So with this, you have no hotspot for one failure. Your root is always alive, and you can basically mount different projects and similar to a Unix side mount level. The testing is underway for federation. Many ecosystems such as Pig have completed the testing, but the real load testing will happen when multiple clusters are upgraded to 23 in the Yahoo, right? Also, adoption of federation will allow better consolidation for Yahoo grids. Definitely save storage space for us because many of these keys are duplicated for us in this case. So let's look on some of the impact on end users and ecosystem developers that Hadoop 23 gets, right? So many of you are familiar with Hadoop Home, right? But there are new environment variables that you need to set when you run Hadoop 23, right? There are many commands that will still work as expected, but many they will be replicated, right? For example, instead of Hadoop Q, you have used Map-Reduce. Better to use the new APIs, new what you can use it in your application code because you don't want to rely on code once, right? Then you will replicate it anytime. All the Map-Reduce applications that our customers basically use, hopefully they just had to recompile. They didn't have to do major changes to their code to get it running. So that was a good feature that save a lot of support time. Right? Because if all these applications had to be again rewritten, that would be a big problem for the hundreds of customers that we have. Right? So that was really saved the day for most of solutions. Right? One thing was all of them required a recompile, and most of the streaming applications Hadoop Pipe, and all of them required a recompile, and things were good for us. So one big problem that we faced when doing integration of Hadoop 23 was we had two separate jobs that we released, both with the name pig.jar in different folders. Right? This was a big packaging issue that we had to undergo. So even if you take outside, you see two pig.jars, one compiled with Hadoop 20, other compiled with Hadoop 23. That caused a lot of problems for Uzi users who basically did not know which pig.jar this was and stopped it inside their workflow, right? And then later discovered problems we did not have. This normally happened. Also, these scripts, since it's a higher level language, we didn't face any issues, right? These scripts should run in any version of Hadoop because it uses its own language and it's written in big language, right? Also, we didn't have to face this right now because Pig just underwent federation testing, but we had to replace the HDFS schema with UFS. But there were loaders and storers that were written in Pig that relied on Hadoop APIs that had to be recompiled, right? And in some cases, there was code changes that were required for Pig. This is directly from the developers as well as customers. That's what I got from that. Hadoop 23 compatibility with Uzi. Uzi 3.14 works with Hadoop 23. Luckily, no changes because again it's written in XML, so you don't have to change anything in the Uzi workflow definition itself. But if you're relying on Java code or you're relying on Java files, you have to make sure that your Java file is compiled to Hadoop 23 before it can be run in Uzi. That was the biggest problem that we faced. Because many times you spend a lot of cycles in debugging what the error was when we don't know which Java file you're using. Also, we left it to the users, and hopefully, the user picked up the right pig.jar, which was compatible with Hadoop 23 for the three actions. So these were the challenges that Uzi development faced when they were basically integrating with Hadoop 23. Right? The biggest challenge they faced was basically the daemon bits. It was hard for them to basically get these iterations going, right? And and this added some significant development time for that, right? To make that closely compatible with Hadoop 23. Also, another big challenge was basically the configurations of the queues as well as container allocations required sort of revisiting and redesign because they are not the same as Map-Reduce slots. So slightly different code change definitely required. Also, Hadoop 23 since it's always undergoing constant bug fixes and deployments, so every new release that we get out of Hadoop 23, again recompile, make sure it's works, make sure it's certified. All that adds more time. Right? Whenever new version of Hadoop 23 comes, all those other ecosystems are again pushed ahead. So that is one big problem that we faced, just because this Hadoop 23 was raw, right? It was getting stabilized. For high Hadoop 23 work, hopefully without much problems, just take Hive scripts, make them run. As long as you're written up jars in Hadoop 23 and then you require to recompile. So that is the only problem that we faced if it was a Hive script, right? But the dev faced a lot of challenges when basically integrating with Hive, right? So Yahoo dev team was working on Hive, get it certified with Hadoop 23. Basically had some problem with the mini MR cluster that was not there, so extra amount of time in debugging, rewriting test cases, right? Also, there was a big change in Hadoop 23 in the way it creates empty directories, right? There is something like make dir in Hadoop 20. This is different from make dir in Hadoop 20, right? And that caused a big problem in many test cases, right? And that also sucked up a lot of time for the developers, programming things, right? And also, same thing with Map-Reduce APIs. High requests on Map-Reduce APIs, it would be good to move to Map-Reduce and save something, right? For example, Pig has done that and we save lesser amount of time, right? HDFS, no problems as such. The only thing is that HDFS 0.4 is certified to work with Hadoop 23 and we are good to go. Another big change with Hadoop 23 that our customers faced was with this log API and log format, right? So many of the tools that are written in Hadoop 23 basically required the logs to be in a certain format. And in Hadoop 23, the whole format changed. It was average serialization, and it was written in JSON and things like that. So many of our tools that were written were using the default job history parser, and that was not there. So we had to make sure that, for example, Hadoop had to be rewritten the new job history parser and new counters and new things to basically work, right? So all of that required significant development time. Hadoop 23 has a new feature known as hierarchical queues, wherein you basically have a top level queue and then you can have sub queues within it, right? So if you have a business unit and you have many projects in the business unit, you can basically allocate the business unit some percentage of the queue and then have sub queues underneath, right? Having the capacity. The biggest thing that we faced was we just configured it as the same flat level queue because we didn't want to disturb customer SLAs. But we are hopefully in the future we are going to have this hierarchical queue introduced inside our inside each business unit, right? Also, there is current work that we are doing to certify Hadoop 23 to HDFS, right? And 64-bit or 32-bit needs to be seen, but mostly it will be 32-bit for the time being. There is also significant effort being conducted to make sure that they run, right? Because we want to run on the latest Java releases, right? And also we have seen problems with JDK 1.7 64-bit when running between these ecosystems, right? Just the way that Java is. And for the operations of services, this is what the experiences that we found, right? When we transitioned from the Hadoop 1.0 game node to the Hadoop 23 game node, the transition was fairly simple, no problem, right? Just run some script and the Hadoop game node is up, no problems at all, right? But there are other issues that the main node had, for example, wherein nowadays all the logs are basically stored, the task pattern logs are stored on the HDFS. So many of these tasks are contacting the main node and trying to write back to the HDFS. So we ran out of namespace descriptor. So there are other issues that once the main node is operating, but just to get the main node up was not a big challenge. So none of our data was lost, no customer data was lost. So that's a good thing. one thing is we basically matched the map-reduce slots from Hadoop 22 containers in Hadoop 23. We did that because we based our map-reduce slot based on memory, so that helped us to quickly transition. One more big roadblock we always hit was basically scheduling and planning this migration of 100 or 150 customers is